So, today I have the Vtoman, I'm not entirely sure how you say that, but the Vtoman power station. And I've picked this one to show you because it does something different, something interesting that I haven't seen on another power station as yet. This one claims to be able to jump start vehicles. So besides all the AC and normal DC outputs, it's supposed to have a big DC jump starty power output. So in this video, I am going to take it apart, test it, do a capacity test, and then at some point we'll go and see if we can jump start the old drift beast down in the warehouse. So I'm gonna open it, take out its box, and take it apart and show you it doing its things. Where's my Stalin knife? Feel free to skip ahead. That's what the skippy bits of the controls are for. If you don't want to watch a bit, don't watch a bit, just skip ahead. That's exactly what it's for. But let's see what is in the box. Please, open. Oh, sweet, stickers. The easiest way to a man's heart. Free stickers. That's nice. I wish everybody could give me free stickers. I like stickers. Stickers are good fun. And a manual. We'll read that later. That looks like a box of bits. What is in your box of bits? A power charging cable, IEC connector, and a 12 volt connector with a barrel connector on the end of it, and a USB-C to C, for charging, that kind, and a USB-A to C for charging. Marvellous. Right, set them over there. Now, can I get this out of here without hurting myself? As it is, a fairly heavy beast, obviously. Everything is with LiFePO5 batteries. Oh, there we go, right on the floor, go. Lovely. Here we are. Cheddar, that's the back, David. Oh, turn around. That is a better. Whew, here we go. Oh, I suppose the first thing we should do is do the taking the plastic off the front. And then do it nice and slowly so it's ASMR. Nah, don't do ASMR nonsense. There we go, it's currently at 83% capacity. Smashing. Right, not going to read the manual because we don't do manuals here. But I've noticed, the very first thing I noticed is there is a top flap. What is inside top flap? Nothing. Nothing. Nothing? Really? Nothing. Have I missed something in the box? What I'm looking for in the box is the jumper cables. Are they somehow attached mysteriously to the... No? Any secret side panels? No, there's a light on the back. Oh, there it goes. That's a good light. Apart from the flashing. Start up the flashing, please. No, there's no... Right, okay, so... Granted, it's not even... That is a very specific jump cable. That one's not. That one's a fairly standard port, but the jumper cable has got a wire down the middle of it. It's got 2 pins and an output. That's disappointing. What have we got on this side? The IEC connector for charging, an Anderson port for solar input, and a barrel plug for the DC, car socket charging. We've got car socket for running car sockets, your USBs. Wait, oh, there's USB-C. I was going to say I don't see USB-C, but that's because it's staring in your face. And AC output. Okay, so in there's where I kind of expected the jump leads to be. That would have been a good place to put them. Right, I'm going to find things to take this apart with. It looks like it's got 4 big hex on the top for starters. So let's start there. Right, so I've had a rummage about and I found 2 sets of, jump starter cables from your typical jump starter battery packs, and none of them are that kind of thing. That one doesn't go anywhere like that, and that one's the wrong gender. It's absolutely round the wrong way. That doesn't fit. This is it's marked down as an EC5, whatever EC5 connector that is, which looks like it should be close, but that one's got two round on the outside pins, and that's a round and a square, and it does not fit either. So I'm going to have to go and email Vtoman and say, hey, where are the jumper cables? Because I'd quite like to see it jumpering something. That's kind of its, you know, special thing it does. Otherwise, it's just basically a power station. But let us start by taking off these big hex around the top. And I'm not going to make you watch me take this apart. I will bring you back once I have it in bits. So that was a fairly involved process. There's quite a lot of screws in this. There's the 4 you can see at the top. There's 4 hidden under the feet at the bottom. I wish they would stop doing that. I do wish the manufacturers stop hiding screws. Just put screws where we can get to them. We're going to take it apart. If we're going to take it apart, putting them under the feet, just minor inconveniences by having to stick feet back on. Then the side panels have to come off. There's more screws in there. There's more screws underneath. There's screws for the handle. There's a lot of screws. It's a lot of screw bits to put together, but we should end up with like 2 halves now. Right, well, that was truly unpleasant, but I've got about as far as I can get, because I'll show you why. Let me bring you in. So that was the big metal box that was sitting on top of the cells. Its lid was just taped on it in place, which confused me for a little bit, wondering how to get into it, but it was just tape. So this is as far as I can get this without unplugging every single thing on the BMS board and unsoldering some of the wires. So that is the back of what would be the jump start port is in there. That's a jump start, and look at this, how short that wire is that connects there. That's why I couldn't get the front panel to come off, because they obviously put the battery in and then at the same time connect and solder everything together at the same time. But apart from that, the BMS, there's its upside down name number in there, and then I'll zoom in on that, and then you can sort yourselves out, and let me move that wire for you. What is that? PB58 BMS V1 2022 1116. So that is indeed the BMS, which connects to, as well as there is that box, black box at the back there, is a solar MPPT controller, so it says, and its wires go out, over and join up to the other side where the solar input is, and also come back onto the BMS itself. This is the box that's on the top, which I presume, well, to be the inverter board, going by all the MOSFETs, giant capacitors, transformers, and the bits here that say AC in and AC out. So that must do all the control and switching of input, mains power, and output to the main supply, which are the plugs down there. I'd love to take it out further, but as I say, I'd have to unsolder and undo every single one of those wires on the BMS. And I'm not doing that because I'm not in the mood for that today, because I don't have to, because it's not broken, so we're not going to do that. Right. Anything else? Oh, this board up here is pretty nicely conformal coated. I don't know if you can see the shininess of the board itself. It's pretty heavily coated in the old conformal coating varnishy stuff. The only exception being these AC connections don't have anything on them. Everything else is pretty well coated. Yeah, so I think now, well, the cells, Jesus David, the cells to be, they're big and square, so I don't know if they're big square pouchy cells or if they are big square blocks, but there is a barcode here that I will zoom in on. I will even take a screenshot and turn it around the right way for you, and then we can scan it and look at it once we're back on a real computer. Hopefully that'll tell us what cells it is. But I wonder if, being the big pouchy type cells, they'll be good for obviously the jump start current, which will be lots and lots and lots of current for a very short amount of time. Well, I suppose I better put this back together and then we can do some more tests. Right, I'll put this back together and then we'll perhaps do some more tests, like capacity and actual output, and then maybe get the thermal imager and have a look at it doing things. Right, let's go and do things. Okay, it is mostly back together. Oh, I just forgot to say, the case is actually polycarbonate ABS, so it's a nicely made case and it is plenty strong and durable. I've just got the top and the sides to put back on, but I wanted to run it just now and then we can take the inside metal lid back off and do a thermal image once I go back inside and get the thermal imaging camera. But for the moment, let's turn it on and look at its things. Right, that's the kind of half on. If you press it once, it tells you the capacity. If you press it again, it turns the AC on. And then it goes through a self-check of all the fans. And it does have a runtime. Once we plug something in, we'll find out what the runtime shows as. And for my power source, I'm using the good old halogen heater. So let us plug in the halogen heater into that in there and turn the first 400 watts on, hopefully. Right, let's see. There we go. 400 watts. And at 400 watts, we've got a runtime of 2.7 hours at 83% capacity. Right, let's try then 800 odd watts. There we go. 791 watts. Go another one. Right, that's the full 1100 watts. It's going to run for just under an hour and hopefully not melt all this polycarbonate stuff over here. Maybe I should move that out of the way. Let me just put that slightly further away so as not to melt it on its first day. But yeah, that appears to be doing the thing. As of yet, the fans are not running, so it's obviously not hot enough. But that's much like most power stations, they don't run the fans until they absolutely need to run the fans. Right, okay, so that's definitely doing it. It's doing the thing. It's making power and heating up with the halogen here. Can you see the halogen here? Okay, it's over here. It is the bright light source of halogen heat. Ha, it's hot. Sweet. I'm glad it does it, and I'm glad it does the thing where it doesn't run the fans constantly. That is a nice thing, where it only runs them when it needs to run them. Right, now I suppose the age-old question of will it run a diesel heater off of the 12 volt supply? So we'll turn the AC off. I'll plug my diesel heater in, turn the DC on. Right, DC's on, that's on. We're ready to start up. This is just a max speed and rods all in one. So let's turn it on. Start to work. No! So there you go, that answers that question. There is not enough current from the 12 volt DC output to start a diesel heater. Right, that answered that question. I imagine though, there would be enough from the jump starter bit to start a diesel heater, which is disappointing. I mean, that we don't have the jumper cables that we could test it out with. But yeah, DC inputs 200 watts, but the DC output is still just going to be nearly almost 10 amps. And yet, as we know, with some heaters, this one included, 10 amps obviously isn't enough to start said heater. Wait, I do have, wait, hold on, let me see. We have a DC clamp meter right here. DC clamp meter. I need a 20 amp range. It's DC, 0 out. Let's turn the DC back on. DC's on. We'll put our clamp meter over one of the terminals and plug it in. Right. So we've got a resting current of 450 milliamps, which makes sense. And then let us do a quick start. It appeared to get to 2 amps before it cut out. That's annoying. Is there a bit to show? Max? No, no. Sadly, it's not. This clamp here doesn't have a max hold. That's very disappointing. Okay, but we saw not a lot of amps coming out of the 12 volt side, which is a shame because it would have been nice to run a diesel heater off of it, but alas, that is not possible. Alright, okay, what I'm going to do now is plug the halogen heater in, flatten the batteries, charge it up, and then do a capacity test, and I'll bring you back once I've done all of those things and have my results. I'm not going to make you watch me flatten and charge batteries. Right, while I discharge the batteries with the halogen heater, I thought we would get the doogie out and do a bit of thermal imaging on the insides while they're hot. I presume they're hot. Let's see. Oh, they're plenty hot and plenty of heat in here. Let's do video and start recording. Okay, these aren't heat reflections. This is all just heat from things. What's that bit? It's like I'm guessing there's a ground or ground positive plane in behind that. Yeah, that's what it is. It's the ground and positive plane underneath that plug. It's hot on there. What is that hot spot? Let's just run over the board first, initially. Ooh, what's that down in there? What's the back of something? Right, I need to, once we've swept over the board, some of that's reflection definitely, because it's moving with me. It's just reflection of me. But there's those MOSFETs or voltage regulators, they're plenty warm in behind there. I mean, granted, yes, right, the fans are running, they're still actually blowing over the majority of things. Those are the tops. Oh, it's a top of a transformer. Right, let's switch the image thing, not to that one, and then we can see what the thing that we're actually, which way do we want to go? Bit more heat. What's the hottest spots? So that is the top of that, not the relay, those little resistors. Yes, there's a bank of resistors down there and they're slightly warm. What else have we got? Well, in front of, let me get my distances right. In front of those two capacitors there's a diode. There's a very hot diode down there. And over here, let's just, I mean the MOSFETs / voltage regulators are supposed to be hot. Yeah, and then the back of, it's the back of the jumper plugs. There's something on there. Is it the back of the jumper? No, it's not the jumper plugs, it's the top right hand corner of the front display panel. Perhaps it's a current shunt for measuring the current. But yeah, I've also just realised that I haven't plugged something back in. I have not plugged in the jumper ports. Well, one side of the jumper port. Okay, I'll need to plug that back in. But it's not worryingly hot. There's nothing unnervingly warm. Right, let me just put this back to normal. Nope, dry infrared, pure infrared. Hold on, I'll set you down a second. See there, let's put the lid back on. Right, can we peer down the inside with the thermal imaging now? Well, that's a pretty good strong fan. Right, we're going to peer in here. Oh, I forgot it doesn't do sideways. Yeah, everything's still pretty hot in there. Right, okay, that's good. I've also noticed there's a green flashing light. I don't know if there's, I'll need to get the other phone out and see if there's any actual Bluetoothiness to connect to around about here. Nope, there's just my two batteries. Right, okay, never mind. Right, now we've seen the thermals, I'm just gonna leave that running to discharge, and then we'll come back once it's flat, plug in the power meter on the wall and charge up and see its capacity. Okay, I initially did the capacity test with the halogen heater plugged into, no, I initially did it on the charge side where I plugged the IEC plug from the thing into the unit and charged it from the wall via thing, but I didn't come back in time and it doesn't consume zero power once it gets to fully charged. It was sitting there using, I remember, was it like 5 watts of idle, just sitting there doing nothing, so obviously that added up and gave me a false reading. So for the second test, I plugged the power meter into the actual unit itself and did it that way. Let me zoom in. So that is the 1.2 kilowatt hours that the halogen heater consumed from the heater, no, from the power station until it was empty. The rated capacity of the said power station is, where is it? 1,548 watt hours. So we got 1,206 watt hours, which is much of muchness. It is within a margin of error, and obviously it's not perfect power, you know, consumption. It's not a perfect 100% efficiency. It's going to be in the 90s or the 80s. So it is pretty close to the capacity it's supposed to be. The only reason we're testing this is some things have got wildly varying capacities as to what they're supposed to get. We kind of went over the unit. As I say, it's the solar input and the mains input, and it does charge at 1500 watts. I'll put an image on screen of me charging it. It did do the 1500 watts, and that charges it from 0 to fully charged in about an hour. Yeah, right, okay. Let me just rid of this thing. Did I mention there's one fan in the side for cooling the batteries, and it just blows out from the other side, and for the what we call inverter, the inverter body on top, it's got 2 fans, but just in one direction, either pulling or pushing the hot air going through. But other than that, yeah, it's done so far all the things it's supposed to do. It outputs the you know, 1500 watts and, well, 3000 peak. It's run the halogen heater. Didn't run the diesel heater from the 12 volt supply, but that's not unusual anymore. And the saddest thing is that we didn't get any jumper cables to go with the heater, so we can't even test the jumper capacity, you know, the output capacity, see if we could start something. Hopefully, if we get a set of jumper cables sent, I'll take this and see if we can jump start a car or two and see if it's good for jump starting. The other port on the other side is for battery extensions. You can buy, it's either more units that look like this but with no screen that in the battery, or they do a slightly smaller one, and they all sit on top of the things. They're stackable, so you can make a stack of batteries to extend the capacity. So all in all, it's not a bad little unit, and last time I looked on the website, it's relatively cheap for what you're getting. Oh, I forgot the light on the back. I'm not entirely sure which sequence of events turns the light on, but a long press. Right, does it show you? Oh no, it's just showing them. So it could run that light at maximum power for 95 hours. Yeah. The first one must be to wake it up. Like when you first tap a thing and it wakes the unit up. But yeah, it's got a light as well, which is handy. Yeah, I think I've gone over all the things I can go over and show you it doing. It runs the thing, it charges fast, it's got good capacity and decent output. But yeah, just a shame about the jumpers. But hopefully we'll cover that in another video. Any comments, questions, anything like that, please leave them down below and I will try my very best to answer them. And as always, thanks for watching.